Hi, my name is Erin McDonald and I'm an Associate Product Manager for the Laser Interferometer line here at ZYGO Corporation, division of Amatech. We're at the booth at the show today at booth 1342 if you'd like to come visit us. Today I'm going to be talking about one of the problems that we see very commonly in metrology, which is measuring plane parallel optics and thin glass optics in particular. Traditional phase-shifting interferometers have always struggled with measuring plane parallel optics because you get an interference from the back surface. The phase-shifting method is not able to differentiate one surface from the next. There have been many solutions to try to figure this out, either using a short coherence measurement method or also using a wavelength tuning method. Wavelength tuning is the solution that we found to be best here at ZYGO. What you're able to do when you're measuring with a wavelength tuning system is, in addition to just looking at the front surface of thin glass or a plane parallel optic, you're also able to isolate the back surface and measure that as well as the optical thickness variation and physical thickness variation and homogeneity. What gets even more difficult is when you start getting thinner and thinner parts. It's much more difficult to differentiate between the two surfaces. You just don't have enough space, and it's much harder to frustrate the back surface in a traditional sense. Also, these parts are very, very susceptible to the environment. So you want to make sure that you fixture them nicely without deforming them. So you want to fixture them kind of either holding in the middle or holding something where it's very loosely held. The other thing that's important is you want to be able to look at, if you're interested in optical thickness variation, you want to look at the front surface and the optical thickness variation at the same time. Because if you measure the front surface via short coherence and then the optical thickness variation, your environment's going to change in between and you're not going to be able to back out that error. When you're using a wavelength shifting type solution, you measure front surface, back surface, optical thickness variation, homogeneity, all in one shot, and so you know that the environment didn't change in between. That allows you to get the most confidence in your metrology and also make sure that you have the most repeatable measurement going forward. We do have a Verifier HD MST that is capable of both thin glass measurement down to an optical thickness of about 1 millimeter, physical thickness with a standard index of about 0.65 millimeters, 650 microns, here on the show floor today. So if you have any plane parallel optics, thin glass or otherwise, please feel free to come visit us at booth 1342. Thanks.